Hey guys, today we're going to be talking about, we're starting a new unit here. This unit is going to be about what's called kinematics. And kinematics is sort of just how things move. It's the study of really motion, which is a big concern of physics because we want to know how things ultimately interact. And they interact a lot of times by moving around and bumping into each other. So you should have this PowerPoint here. We're going to go through a couple of things together. So first of all, Wally West is able to travel 300 meters in 0.8 seconds, whereas Barry Allen is able to travel 300 meters in 1 second. Which flash is faster and why? Well, it's probably obvious to you, right? It's got to be Wally West. But why is he faster? The reason why he's faster is because, not because he travels further. They traveled the same distance, but rather he traveled that distance in less time. And so speed is what we're talking about today. Speed is a relationship between distance and time. You can travel a very far distance, but you can travel that distance. If you're going slow, it's going to take you a long time to cover that distance. Whereas if you're traveling fast, you're going to cover that distance in a much shorter amount of time. So this is the equation for speed. I'm going to see, I don't know, my head might be in the way. I know that it was in the way earlier, but you hopefully have this PowerPoint. So if my head's in the way, just open up the PowerPoint. You have the equation there. You can write that down if you need to. But speed is distance divided by time. We're going to use this equation quite a bit. All right, so hopefully you got that written down. You can pause the video to do that. So what is our unit for speed? Well, let's think about this, right? Speed is distance divided by time. So to find the unit of speed, we're going to do dimensional analysis. We're going to take a unit of distance and divide it by a unit of time. But as we talked about previously, in the metric system, there is the standard unit. So what is the standard unit of distance? It's a meter divided by what is the standard unit of time? It's a second. So speed is measured in meters per second. And that is the unit of the standard, the metric unit of speed, meters per second. Now we measure speeds typically in miles per hour, right? But notice again, it's a unit of distance divided by a unit of time. And that's what you're going to see. Whenever we talk about speed, speed is any unit of distance divided by any unit of time. That is a speed. They can be really strange units, right? They might be centimeters per century, right? That might be the speed that we use to measure the shift of tectonic plates. So you can have any unit of distance divided by any unit of time, but the standard unit, the standard metric unit is meters per second. A lot of times just abbreviated M/S. And once again, it's meters per second might be, how many meters per how many seconds is what that means. So let's do a couple problems. I'll need to switch over here. All right. So it says a car travels 80 meters in 8 seconds. So this should be pretty simple, straightforward. We're just going to apply our equation for speeds. Well, and there's actually a mistake here. Sorry, I need to change my pen, I guess. There we go. Okay. There's actually a mistake here. This should not say velocity. We're going to talk about velocity and speed probably tomorrow, what the difference is. So this really should say speed. I'll probably change that in the PowerPoint that you have, hopefully right after this video is over. If I don't, then I meant to, so you can change it for yourself, or you can remind me to change it. All right, anyways, let's find the speed. So speed is going to be distance, which is obviously 80 meters, divided by 8 seconds. 80 divided by 8 is 10, and that's meters per second. You could also write this as 10 meters per 1 second if you want to. It's a little, you don't need to, but I just want to emphasize it's meters per second, and meters over second. So this car is traveling 10 meters every second. Let's look at another example. Again, hopefully you can already do this. You can go and try to solve this one now. You can probably do it in your head, honestly. Again, these speed problems are pretty simple. So our speed is going to be distance divided by time. So in this case, it's going to be 28 meters divided by 14 seconds. Now, did you pull out a calculator for that? Hopefully not. It's a simple one, 2 meters per second. All right, what's different about this one? It says a flash runs a marathon in 3 seconds. If a marathon is 42.2 kilometers, what is the speed of the flash in meters per second? All right. So here, what's different? Let's just start with speed is distance divided by time. So speed is going to be, our distance is 42.2, but be careful, 42.2 kilometers divided by 3 seconds. Now, notice that if I do this, which I can just divide this time I probably will use a calculator, that's kind of tough to do. 42.2 divided by 3 is 14.06 repeating, so we'll just say 14.1. So I would get 14.1, but be careful because that's not 14.1 meters per second. That's 14.1 kilometers per second. So actually, if I want this in meters per second, I have to convert, right? So you see, converting is not going away. I'm going to take kilometers to the bottom, meters in the top. 1 kilometer is 1,000 meters, so we get 14. I meant to say 14.1. Sorry, 14.1. So it's 14,100. When we multiply by 1,000, that's meters because the kilometers canceled per second. That's our answer. Now, you can solve for something else, right? We have in this equation speed equals distance divided by time. There are 3 different quantities there. There's speed, there's distance, and there's time. So up to this point, we've been solving for speed, but you can actually solve for, in this case, how long will it take? We're actually going to solve for time. So you would need to I like to do it by rearranging the equation. You can't just plug everything in and then rearrange if you'd like, but I think variable manipulation is an important skill, so I'm going to show you how to do that. A lot of people would be tempted to just move distance to the other side, and they would say, well, divide by distance, and you'd have time by itself, which is sort of true, right? So there's 2 ways you could do this. Let me show you. And of course, that's what I like about math. There's many, many ways you can do it. As long as you follow the rules, the way you do it will be right. So some people might be saying, well, let's get rid of the distance, right? Let's divide by distance on both sides. So we have speed divided by distance equals distance divided by time divided by distance, right? Because we're dividing by distance on both sides, which really is the same. It's just distance in the bottom. They would cancel, right? But this is what I would have, right? I would have speed divided by distance is what's on top here. It's just 1 divided by time. So I actually got time by itself, but I didn't solve for time. I solved for 1 over time. I solved for the inverse of time. So if you want to fix this, just flip both sides, and you can get the final answer here is distance divided by speed equals time divided by 1, but there's really no point in putting it out there. So that's one way you can do it. I would actually do it this way, though. I would multiply both sides by t. So you have speed times time equals distance divided by time. When I multiply by time, this goes away. And so I get speed times time equals distance. And then to get t by itself, divide both sides by speed. Time is distance divided by speed. I hate these bells. And I asked them to turn them off too. I said, please turn off the bells because I'm trying to record. And no, they don't do it. There's no point in them being on. Anyways, time is distance divided by speed. And that's true, so either way you get that. And if you're struggling with this manipulating of variables, you might want to look into that. There are many different resources out there that are great for showing you how to do that. If you can't find them, let me know. Oh, I guess we should actually do the problem, though. We did the hard part, right? Now it's the easy part, right? To get time. So, sorry. Now, a bus is going to travel 5,800 meters with an average velocity of 14 meters per second. How long in seconds will it take the bus to arrive? So then our actual answer, right? Time is distance, 5,800 meters, divided by 14 meters per second. Now, something interesting happens here, right? Here. I'm going to delete, or not delete, but I'm going to erase part of this. kind of obnoxious, but I guess I'll just try to do it real fast. Okay. Yeah, this is not great. All right. Probably a better way to erase this. I really need a better whiteboard, program. So if anybody knows of one, please let me know, because I don't know if you noticed, but I'm using Microsoft Paint, a program that's been around since 1996. So it's possible, it's possible that maybe someone has come up with a better program in the 26 years since then. All right. So, like I was saying, notice what happens here. I want to show you this because I think a lot of people really struggle with dividing fractions for some reason. Okay, I'm going to write this out. 5,800 meters divided by 14 meters per second. Now, how do we divide fractions? The answer is, I don't know. To divide fractions, I simply flip and multiply. And again, I just realized that probably my head is covering this. I'm getting so annoyed. I'm supposed to have a second monitor. We're still waiting on it. I apologize. So I don't know where my head is. It's probably covering up something, but hopefully you can ask questions if you're confused. If you can't see what's in this bottom corner over here, I literally just wrote time is distance divided by speed. Okay, so whenever I have this, I don't know. So there's some kind of thing you may have heard. I don't know, keep flip or something. I don't know. Keep change flip. I think. I don't know. When you divide fractions, you just multiply the reciprocal. Is what I'm trying to get at. So instead of doing divide by 14 meters over seconds, this is the same as It's the same as 5,800 meters times. I'll just skip over here. Times second is on top over 14 meters. And really, you can just put 1 there if you want. So then look, meters cancel, right? Because we're multiplying meters, same thing top and bottom. So they cancel, and I end up with 5,800 seconds divided by 14. And I get 414, we'll say 0.3, and the unit is seconds. So I know it's kind of exaggerated, drawing this out, because you probably already know 5,800 divided by 14, you got the answer. But what I want to show you is that one of the reasons why, I don't know why it's going off now. Okay, probably shouldn't focus on it. One of the reasons why you have to do that, right? One of the reasons, what I'm trying to show you is when I tell you this equation here, right, that we solve for, distance divided by speed is time. We know that must be true from the units because we just took a unit of distance, 5,800 meters, we divided by some speed, which was 14 meters per second, and the units canceled to give us seconds. So that's one way that we can confirm that this is the correct equation. And that's what I mean by that dimensional analysis stuff. If I didn't know what I was doing, but I saw that when I took 5,800 meters and divided by 14 meters per second, I got seconds, that already tells me that in order to get a time, I have to take the distance and divide it by the speed. All right. This will be fast, much faster than the last one, okay, I promise. So Cletus is competing in a drag race with his brand new Ford F-250. He runs this truck with an average speed of 20. Okay, it doesn't matter. I literally started this video, by the way. The bell went off, right? The bell went off, and I was like, oh, the bell's not going to go off for an hour. Well, apparently it went off after 30 minutes. So I timed this video specifically to try to avoid the bell. And here we are. So that's my frustration. All right. Sorry, so Cletus is competing drag race, brand new Ford F-250. He runs this truck with an average speed of 22 meters per second. How far in meters has he traveled after 28 seconds? So this one's going to be much simpler, right? Because we have our equation, speed equals distance divided by time. And we want to solve for what? We want to solve for how far distance. So to get distance by itself, I just need to multiply both sides by t because it'll cancel on this side. And I get speed times time equals distance. Great. So my distance is going to be, in this case, it's 22 meters per second. And watch what happens again with the units. 22 meters per second times my time is 28 seconds. Look what happens. Seconds cancel. So again, the dimensional analysis shows us that when I take the speed and multiply it by time, I get a distance, right? So again, it's just a check on it. We know this is true because that's the unit that we got. So I do 22 meters times 28, I get 616 meters. Okay, like I said, much faster. All right, I'm going to do one more. A moped is able to travel 2.4 kilometers in 12 minutes. What is the speed in meters per second of the moped? All right, so I need to first use my equation. Speed is distance divided by time. 2.4 kilometers divided by 12 minutes. Before I do any math, I'm going to work on the units, right? Because I have kilometers per minute, I don't want that. I want meters per second. So just like we did previously, I can choose which of these I want to get rid of first. I'll get rid of minutes first. So since I want to get rid of minutes, it's in the bottom, has to go in the top over here. And I want to go to seconds. So I know that 1 minute is 60 seconds. Cancel kilometers. Let's get rid of kilometers in the bottom to meters in the top. And I know that 1 kilometer is 1,000 meters. So kilometers cancel. I don't think anything else cancels. The only unit I have left in top is meters. The only unit I have left in bottom is seconds. So again, I know I'm done because I wanted meters per second. That's what I got. So again, the dimensional analysis tells me that I'm done. I don't have to think and like, oh, did I do everything I needed to? So on top, I have 2.4 times 1,000 meters. I get 2,400 meters. On the bottom, I have 12 times 60 seconds. I get 720 seconds. So by the way, what this means is that this moped moves 2,400 meters in 720 seconds. We can simplify that ratio to find the actual speed, and we get 3.3 repeating meters per second. And that's our answer. Okay, hopefully that made sense. I think that the problems you have will be pretty straightforward. Again, I don't expect it to be too hard, but please, as always, please ask if there's something that you're confused about. Again, I'm sure that at some point in this, I probably covered up part of the slide. I'm sorry. Once I have my second monitor, I'll be able to police that a little bit better. But if there's something you missed or you want me to know what I wrote, I'll feel free to ask. And of course, you have the slides, so hopefully that helps. All right. So again, you have an assignment. You have homework today. Practice. It won't take very long. I don't think. It should be pretty straightforward. And then tomorrow we'll talk about velocity, which is similar but slightly different than speed. I forgot to mention there is one more slide at the end. There's one more slide at the end. It's got a video on it. You're not required to watch that. I think it's pretty fascinating. I think it's definitely worth watching. But I don't know how little or time you have with your work. Okay. So as always, let me know. Please contact me if there's something you need. Otherwise, have a good day. Bye.